So, welcome to the first part of talking about volumes, arc lengths, and surfaces. Okay, the first method we're going to talk about is the infamous disk method. Okay, now the disk method is actually thinking about breaking up an object, or actually doing a rotation about a fixed axis, and then breaking that object up into all of the disks that make up the actual shape, and you can actually work with it. Okay. Now the cool thing is, just so you know, is that this a of x, area of x, is actually going to be pi r squared, what we're typically normally used to. Okay, and it's going to be r of x in terms, it's going to be a function of radius in terms of x. This d of x is actually going to be the height, so that's how we get our volume in actually working with this. Now the first thing you want to do is you want to graph it so you can actually see what you're working with and just see how it's actually going to go. Okay? Alright, so taking a look at our actual graph, this is what the graph of a square root function is going to look like. Alright, this is going to be our axis right here that we're going to spin about, and this is going to be the top part that we're going to stop off. So if you were to imagine it actually spinning around, it should look something like this. Y equals negative square root of x. There we go. Okay. So it should be some kind of disk inside shape here. Now, if we had a secondary function that came up, like let's say right here, and then went up to right here, you know, this intersection, what you would do is be dealing with the washer method, okay? But for right now, we are just dealing with the disk method as we work with this, okay? Alright, so that's the shape that we're actually dealing with. So what you want to be able to do is just to be able to think of a small disk in here. Okay, and remember there's going to be an infinite amount of them that we're working with. Okay, and it's going to go top to bottom, just working with it that way. And so what we're going to be using is the radius. Now the radius as terms of function is going to be the actual function of y equals the square root of x. So our radius is actually going to be square root of x as we go up. So as you can see, the higher in the actual cylindrical disc shape we're getting, the more wider it gets, and the lower, obviously, the closer to x equals 0, we are actually getting lower in value. Okay. All right. So let's go back and look at our actual calculations. All right. So we plug in everything. So volume equals. Okay, and this is going to be from 0 to 4. Okay, and it's going to be pi times the square root, well, not, x to the 1/2 is what we probably want to be working with here. Alright, so there's our actual function of it, and then here's d of x. Okay, and so when we actually work on this way, when we do the integral of it, we're going to have pi out front, so we are literally just putting the pi out here, 227. Okay, and then on the inside, we're getting rid of the pi, and we're just dealing with the integral of x to the 1/2. Okay, so on the outside, this is going to be pi times 2/3 x to the 3/2. Okay, and we are going to be going from 0 to 4 of this. Okay. Now obviously when we do the 0, we're not going to be really subtracting anything, so all we need to do is plug in 4. So this is going to be, well, you can just go ahead and write it out. It should be, let me see, it should be approximately 16.755 units, whatever you want to use for your cube units. So units cubed. Okay. All right. Now, when you guys are working with this, just make sure that if you are spinning around, and there's actually a really good photo. Let me show you. All right, and so this actually, this is from Krista King over at integralcalc.com, so she gets all the credit for writing this bad boy out. I just didn't want to reproduce it. Okay, but if you take a look at it, you can find volumes by disks and washers, and we'll definitely be coming back to this a little bit later. But the rotation about the x-axis or y equals, you're definitely going to be doing writing your functions in the form of f of x equals y, and it's just going to be the f of x. Now obviously washers is going to be a little bit different. Okay, and we're going to be dealing with this type of shape. So if we find out that we get to this part or to this part right here, okay, we can actually figure out the rest from there, okay, as we work with it. All right, so please understand, as we work with this stuff, use this chart like no other, just to help out when you're doing volumes by disks and washers, because it'll just help you organize your information as to what do I do. Like, for example, I am rotating about the y-axis. How do I set up my equation? Well, my equation should be x equals a function in terms of y. Okay, and as I write it, it should really just start to come out and float out like this. It really just does make sense, okay? All right. And if you just remember that when you're using the disk method that you're going to be using pi r squared as your original function in terms of x, you should be totally fine with this, okay? All right. That's it for working with the disk method. I'll talk to you later. Bye.